Hello friends, today we are going to solve a numerical problem based on the single rope deep groove ball bearing selection procedure. I have already explained the whole procedure of selection of single row deep groove ball bearing in the previous lecture. So before going this particular lecture, I request you to kindly go through my first lecture on the selection of single row deep groove ball bearing, in which I have in detail explained the selection procedure of this type of single row deep groove ball bearing. So without wasting time, let's start the topic. So friends, this is a numerical problem on the single row deep groove ball bearing selection procedure. Now friends, the problem is based on the selection of single row deep groove ball bearing, for which the data required is given on this page. So see the friend, this is the radial load acting on the bearing. It is given as 6 kN. The axial load is given as 4 kN. The RPM of the shaft is given as 1000 RPM. The diameter of the shaft is given as 60 mm, and the life of the bearing in hours is given as 20,000 hours. So friends, let's start the design process or selection process. So friends, first of all, go to my previous lecture on the selection of single row deep groove ball bearing, in which I have explained all the steps. So I am following all those steps and designing for that purpose. So friends, let's start the topic. Step number 1. So in first step, it is the equivalent dynamic load determination. So equivalent dynamic load is given as XRV F radial plus YA F axial, where XR is the radial load factor and YA is the axial load factor, and V is the race rotation factor, and F radial and F axial can be taken from this. Okay friends, now the radial load factor is first assumed on the basis of trial and error approach. So I have explained in the previous lecture how to select in the trial and error approach. So it is taken as 0.55 and the radial load factor is taken as 1.5. For this you have to see my previous lecture how I have taken this. Okay friend, now the race rotation factor is taken as 1 because we have assumed that the inner race is rotating and the outer race is stationary. So friends, we will calculate the equivalent dynamic load in the step number 1. In the step number 2, we will calculate the life in million revolution. Okay friend, for this I have to substitute the speed of the general in RPM here, and the life in hour we have to substitute at 20,000 hour. So we will arrive at 1200 million revolution. Okay friends, so we will calculate the life of the bearing in million revolution. So the next step is the calculation of the dynamic load capacity. So how we will calculate dynamic load capacity? Using this formula, as I have already explained you in the previous lecture. So we will accordingly arrive at this value. How? We will take the EDL from the step number 1 and we will take the L in million revolution from the step number 2. So friend, now we will see the step number 4. In the step number 4, we will see that corresponding to the diameter of the shaft and the dynamic load capacity as calculated from the step number 3, we will see for the static load capacity. How friend? Let's see this, how we will see. So friends, we have calculated that the dynamic load capacity is 82882.8 Newton. So we will see that diameter of the shaft is 60 mm. So friends, for the diameter of the shaft 60 mm and the dynamic load capacity 82882.8 Newton, it will lie somewhere in between this value and this value. So we will take a higher value, that is 109000 as the dynamic load capacity, and corresponding to this we will select the static load capacity at 69500. So note it down, C naught is equal to 69500. So friends, again coming to this slide, we will select the value of C naught as 69500 from the bearing catalog. Okay friend, now friend, so we will find in the next step we will find the ratio F axial by C naught, that is the static load capacity. Okay friend, now the ratio comes out to be this. Okay friend, write it down. Now in the next step we will calculate the ratio F axial by F radial, and the ratio will come out to be this. Okay friend, now in the step number 8, what we will do, we will calculate the value of E. How we will calculate E? In step number 8 we have to find the value of E. How we will find the value of E? We will look into the load factor table. Now corresponding to the value of FXCL by C naught, which is 0.05755, we will see in the load factor table what is the value of E. So our value of FXCL by C naught is somewhere between this value, these two values, that is 0.040 to 0.071. The value of our F naught by C naught is FXCL by C naught is 0.57. So 0.57 lies somewhere in between these two values. Now friend, go horizontally and see the value of E. So the value of E will lie between 0.25 to 0.27. This is 0.7 because there is no clarity, but I have in my notes it is 0.27. So it is 0.27. So our value of E will lie between 0.25 to 0.27, somewhere in between. Okay friend, so let take E as 0.26. It is between 0.25 and 0.27. The value of E is 0.26. Okay friend, now compare this value of E with the FXCL and F radial, this ratio by this ratio. Okay friend, so our FXCL by F radial value is 0.666 and our value of E is 0.26 as I have determined from here. Okay friend, so as we see that the value of E which is 0.26 is less than FXCL by F radial ratio. Okay friend, because it is 0.666, because 0.26 is less than 0.666. So this condition will arrive, that is F axial by F radial is greater than E. So friends, in the table we will see this condition, the value of radial load factor and the axial load factor will be according to this condition. So according to this condition, if we look at the F axial by C naught value, okay friend, which was lying somewhere in between, that is 0.0577 was the value of axial by C naught. So we will go horizontally and see somewhere in between the value of F axial by F radial will lie. So friends, let us take the value of X radial as 0.55 because it is constant, and the value of radial load factor which is lie somewhere in between as 1.7. The value of YA is equal to 1.7 and the value of XR is equal to 0.55. Okay friend, now we will arrive at this value. So friend, let us see the step number 10. So in the step number 10 friend, the value of XR and YA we have determined for this condition as 0.55 and YA is equal to 1.7. Now friend, in the step number 11 we will find the equivalent dynamic load using the same formula, this formula. So we will find the value of equivalent dynamic load. Okay friends, by putting the value of radial load as the 6 kilonewton and the value of axial load as the 4 kilonewton, and the value of radial load factor is equal to this and the value of axial load factor is equal to this. So friend, we will calculate the value of equivalent dynamic load. Now friend, look at the step number 12. In step number 12 we will find out the dynamic load capacity. So dynamic load capacity can again we find out using this formula which was used earlier in the step number 3. So friend, again we will calculate the dynamic load capacity, and the equivalent dynamic load will be taken from the step number 11 here, and life in million revolution is same. So friend, as calculated in the step number 3. Okay friend, the life in million revolution is 1200, which is calculated in the step number 2. Okay friend, from here we will put as 1200. Okay friend, and we will find out the value of dynamic load capacity. Now friend, we have find out the dynamic load capacity, and according to the diameter of the shaft 16 mm given in the question, we will again look at the bearing catalog. Okay friend, so looking at the bearing catalog, this diameter is 60 mm and our dynamic load capacity was coming out to be 89258. That is 89258. It is lying between this value and this value. So we will take a higher value, that is 1.09000, and the value will come out to be for the bearing 6412. So this is the bearing which is selected. So our bearing selected is 6412. So hence the problem is solved. So our bearing 6412. Each of the number is having a particular meaning here, which I will explain, for which I will make a similar video on the single loop deep groove ball bearing. A next video will be on the bearing designation. Okay friend, so if you like my video, kindly subscribe my video friends, and also press the bell icon. I will be highly thankful to you. So friends, thank you. Let's see you again.